This is the last section for chapter 9. It's a pretty short chapter, so it would have been easy for us to get through and test and be done with it. But that might not happen. Anyways, this is lesson 9.7, and it's about similar triangles. It's pretty easy. We've kind of done it before when we did ratios and proportions, so it's the same kind of process. So let's go. So here we have two triangles. We have triangle run and triangle cab. So if you look at these two triangles, the first thing I want you to notice is up here, how you write it. You use the symbol triangle, and then it doesn't matter what order you put these letters in. And then again, to compare it to this triangle. This symbol right here, that means similar to. So it's not equal to it. Clearly you can see the two triangles are not equal, but they are similar. So how are they similar? Their sides aren't similar, definitely no, but their angles are congruent. And the arcs that they make indicate which angle matches which angle. So you can see that angle A, 2 arcs, is congruent to angle U, 2 arcs. Angle C, 1 arc, is congruent to angle R, 1 arc. And angle B, 3 arcs, is congruent to angle N, which has 3 arcs. Now, if you looked at this, I didn't even need to look at the triangles, because if you match it up when you identify it, you have matched up the sides and the angles. So you can see that angle R is corresponding to and congruent to angle C. Angle U is corresponding to and congruent to angle A, and angle N is corresponding and congruent to angle B. So it matches up. So they are similar triangles because of that. Now, so how can I find this missing measurement? Well, we just create a ratio and a proportion. So, because what we're saying is that these triangles are growing proportionately. Now, if you just look at it, you could figure it out, because you can clearly see it's stretching from from measurement side UR to side AC. It increased by a scale factor, listen to those words, scale factor of 2. 4 times 2 makes 8. So 10 times 2 would make 20 meters. That one was easy because you can see it. Maybe you can't see it all the time. So I always like to show you the mathematical process just in case you can't see it. The way you set up your ratio, I've told you before, matters. So if you decide to do cats over dogs, make sure you do cats over dogs. We've talked about that before. So in this case, I'm going to do side AC, which is 8, over side AB, which is X. Now, when I go over to this one, I need to match it with the corresponding sides. So I went short side, long side, so I need to go short side, long side. And if you switch it, you're not going to get the correct answer. If you remember how to solve a proportion, you know that you need to cross multiply. 8 times 10, 80, divided by 4 is 20, if you remember how to do that correctly. Now, is that the only way I could have set it up? No. I could set it up like this. Short side of the big triangle to short side of the little triangle, long side of the big triangle to long side of the little triangle. See? Still, 8 times 10 divided by 4 is 20. So it works out no matter which way you set it up. You just have to make sure, if you heard my words, that you're setting it up correctly. But again, another way to look at it is to find the scale factor. And that scale factor indicates how much it's stretching by or how much it's shrinking by. So if I go from small to big, I'd say it's stretching by 2. If I went from big to small, I would say it's shrinking by a half. Let's try it again. So look at this one. You can clearly kind of see what's going on. So it looks like that it's shrinking by a half. So then you would do a half of 6 would be 3 inches. If you want to set it up, you can go big triangle long side to big triangle short side equals small triangle long side to small triangle, short side. 4 times 6 is 24. Divided by 8 is 3. So it works. So in this case, a surveyor wants to find the distance RS. So find RS right here. So this funny line right here is the lake. And they're trying to measure the distance across the lake. Because it doesn't make sense that the boat starts on one side of the lake's edge and hands the guy the measuring tape and says, go ahead, drive to the other side. Let's see how long this lake is. That's not how they do it. So it helps when they can construct similar triangles. It will help them measure the distance across. So now how you set your proportion up matters. So be careful on this proportion. If you switch anything, you're going to get the incorrect answer. So I have short side of the small triangle to short side of the big triangle. Longer side of the short to longer of the big. And then you can do your cross multiplying and your dividing. So try that first. And let's see if you can get it. There you go. It's 28 8/10 of a meter across that lake. Same kind of thing. This time they're measuring the distance across the park. Do the same process. I'm going to do short side to short side. And make sure you go back to the small triangle, because I started with the small triangle. Go back to the small triangle and then to the big triangle. Because if you flip anything, you're going to get it wrong. So 8 times 3 is 24. Divided by 5 is approximately 4 8/10 of a mile. Okay, do you know that you can measure something if you have nice bright sunlight out and you're standing next to a very, very large building or tree? You can measure it by your shadow. Next time you might want to try that, right? So suppose the John Hancock Center in Chicago, Illinois casts a 257.5-foot shadow at the same time a nearby tourist casts a 1.5-foot shadow. If the tourist is 6 feet tall, how tall is the John Hancock Center? So here's the John Hancock Center, right here. Then here's the tourist, right here. Best tourist ever. Got a little eye. Got some hair. Little arms. Good to go. Okay. So suppose the John Hancock Center in Chicago, Illinois is casting a 257-foot shadow at the same time a tourist casts a 1 5/10. So when you look, you're going from the eyeball down and over. So this person is casting a shadow that looks like this. Obviously, the shadow's on the ground. It's casting a 1.5-foot shadow. Remember, they're 6 feet tall. So it looks like I'm looking for this right here. Looks like the hypotenuse. The John Hancock, which I drew too close to her, but the John Hancock is doing a 257-foot shadow. So, whoop, bad line, 257-foot shadow. We're looking for how tall this building is. So if you think about it, you can create your triangle. This should have been a straight line, like that. So you have if you want to do it like this, and remember, there's different ways to set up your proportion. This is one way. You can go height of the building to shadow of the building. Then height of the person to shadow of the person. Just like that. and then go ahead and cross multiply and divide those, and you will be able to find out how tall that building is. So you cross multiplied and divided. Hopefully you got 1,030 feet tall. That's how tall that building is. Makes sense. So a man's standing near a building. So here's the man. Yep. I don't know what's going on with him. Here's his hair. Yep, best person ever. They're slightly tilted though. Let's pretend like he's standing up tall. Anyways, their man standing near a building casts a 2.5 foot shadow. So the man is a 2.5 foot shadow. 6 feet tall again. Apparently wherever we are, everybody who lives there is 6 feet tall. Apparently I don't live in that area. And the building, this time I drew it further away, should be a nice straight line, looks really good, is casting a 200 foot shadow. You want to know how tall the building is. So this is how it starts off. Your job is to think about the fact that it does create a right triangle. Remember, it goes from the eyes looking down to the end of their shadow. So there you go. Height of the person, shadow of the person equals height of the building, shadow of the building. And do your cross multiplying divide. And you get 480 feet. Yay, we're done with chapter 9.